In these videos, I use chemicals that can cause burns and respiratory problems. If you are to replicate any of the experiments or procedures shown in my videos, please do so in a fume hood or outside, and please wear suitable gloves when handling acids. Hello everyone, and welcome to my video on recovering gold from a mixed selection of CPU processors. Amongst this pile of CPUs, I have 63 Intel Celeron processors, 31 Intel Pentium 4 processors, 4 Intel Xeon processors, 6 of these large unknown processors, 8 Intel dual-core processors, and finally, 3 individual processors that I'm unsure of. Okay, let's make a start. The first thing I need to do is remove all of the heat sinks. The heat sinks on the green fiber processors are held on by some kind of sealant. To remove them, just run a sharp blade around the outside, and they'll pop off nice and easy. Please be careful when doing this, as one slip with the blade could ruin your day. Wear protective gloves if you need to. Have a little check on the inside of the heatsink, as some contain gold plating on them. This one doesn't, but I'll show you if I come across any. Now, the heat sinks on the black fiber processors are soldered to the chip. These are going to require a bit of heat to remove them. Just grab them with a pair of pliers and heat them until the solder is molten, then slide it off with your blade. I'll be back shortly once they're all done. After around an hour, this is what I'm left with. I have a bucket full of copper heat sinks. I'll save these for precipitating silver from silver nitrate. I also have 7 heat sinks with gold plating on. I still haven't found a cost-effective way of removing the gold from these, so I'll put them to one side for now. The next step is to remove all of the epoxy centers from the black fiber chips. I found the easiest way to do this is to take a chisel and hit either side of the chip. After a couple of hits, the center will fall out. The gold is contained within this black epoxy, so you want to ensure that you remove anything that is left behind. With all the centers removed, we can now finally get after the gold. For the pins, I'm going to try something different. I'm going to have a go at iodine leaching. I have done some reading on the process, and I'm hoping it will be a better alternative to removing all the base metals. For this experiment, I am weighing out 40 grams of potassium iodide. This is being added to 300 milliliters of water. I'm using regular tap water for this. And finally, I'm using 10 grams of iodine crystals. Once mixed together, the solution turns red and is ready to start stripping the electroplated gold from the processor pins. I've stacked up 10 of the Celeron processors. The idea here is to pour on the solution and keep it moving, allowing fresh iodine to come into contact with the gold plating. Iodine dissolves gold by oxidizing it to form gold iodide complexes. After around 10 minutes of swirling the solution around, I poured it off and rinsed one of the chips in a small beaker of water. And check that out. All of the gold plating has been removed. I'm going to carry on with these off camera, and I'll get back to you if there's any changes. I have managed to process 33 of the Celeron chips. The solution has turned a murky yellow color, and it has stopped dissolving the gold, so now it's time to precipitate the gold that has been dissolved. For precipitation, I'll be using ascorbic acid, also known as vitamin C. Vitamin C acts as a reducing agent. This reduces the iodine molecules to iodide ions. The reduced gold precipitates out of the solution as elemental gold. The iodine solution is brown, but the iodide ions are colorless. I'm going to make a saturated solution of vitamin C. I'll pour it in until I get a color change, and I'll leave it to sit overnight. In the meantime, I'll make a start on incinerating the centers of the Celeron processors. The gold bond wires in these chips are held in place and protected by an epoxy resin. To be able to dissolve the gold, this resin first needs to be incinerated. To do this, I'm just going to burn the chips with a blowtorch until no more flames or smoke are produced. I'll get back to you once the incineration is complete. Now that the chips are incinerated, they need to be crushed. For this, I'll be using a pestle and mortar. Then, I'll sieve everything through this 70 mesh screen. Anything that doesn't fit will be put back into the pestle and recrushed until it passes through. If you wish, you could use an electrical grinder or ball mill to crush the chips. I just prefer to do mine by hand. It takes a little longer, but I'm in no rush. Once everything has been carefully ground down, the final product should resemble a fine, powdered substance, just like this. In one of my previous videos, one of the viewers suggested that I should burn the chips to a white ash. So, that's what I'm going to do now.
30 minutes later.
After 30 minutes of burning until it was glowing red, there really wasn't much of a color change. This could be due to the material that was used. I will try again to get it to white ash the next time I burn some chips. Back to the pins, and as you can see, the gold is now settled out. I'll pour off the solution, but I won't discard it, as I'll be regenerating the solution to leach more gold. There's not an amazing amount of gold as the pins are plated with gold around 0.1 to 0.5 micrometers thick, but it will all add up. Also, the gold powder is extremely fine. To regenerate the solution, I will be adding some 3% hydrogen peroxide. The hydrogen peroxide will oxidize the iodide ions to iodine molecules. I've added around 50 milliliters, and now the solution should be ready to go again. I'll clean the gold out of this jug, and I'll load it up with the green fiber chips this time. I'll do a bit more swirling the solution around, and I'll show you the results of using the regenerated solution. As you can see, the regenerated solution worked just as good as the original solution. I'll work through the rest of the green fibers and get back to you shortly. This time, after I completed the green fibers, I noticed a fine, greenish powder settling on the side of the jug. I'm unsure as to whether this is something to do with the regeneration of the solution, or whether the solution is becoming saturated with base metals, and they are settling out. Either way, I'm going to filter the solution this time before dropping the gold out. When I added the vitamin C, the solution didn't lighten up. Instead, it turned darker. This caused me to add in all of the vitamin C solution. I don't think I needed to do that. I'll leave it to settle overnight and I'll make a start on washing the chip ash. Here, I have the chip ash from the centers of the Celeron chips. I've had it soaking for 10 minutes in cold water with a drop of dish soap. This breaks the surface tension of the water and allows everything to settle to the bottom of the jug. What I'll be doing is adding some fresh water, agitating the ash, allowing it to settle and pouring the dirty water off. The idea is that the heavy gold will settle to the bottom of the jug, and what gets poured off is just dirty water. Gold is 19 times more dense than water, so it settles quite quickly. You will be able to see when the washing is completed. You will be able to swirl everything around, and everything settles out within 10 to 20 seconds, leaving clean water behind. The chip ash is now ready to be treated with aqua regia. But before I do that, let's check out the gold from the second precipitation of the regenerated iodine leaching solution. The gold has again precipitated out as an ultrafine powder. I will pour off the solution, leaving behind the gold. Then, I will combine this gold with the gold from the initial precipitation. You will notice that the volume of the leachant has almost doubled since I started this experiment. This is from the water added to the vitamin C, and also the hydrogen peroxide added to oxidize the iodide into iodine. If I were to try this procedure again, I might consider making a more concentrated solution. I might also try adding the vitamin C in its powder form to reduce the increase in volume. I would probably also use a higher concentration of hydrogen peroxide to oxidize the iodine. I'll finish these up and get back to you after the precipitation. It's the next day, and when I looked at the jug, I saw small green crystals had started to form on the glass. I believe the solution has become saturated with base metals, and the green crystals look a lot like copper. I'm going to store the solution for now, and I'll probably try to remove the base metals at a later date. I believe I can add a small amount of sodium hydroxide to remove the base metals, then regenerate the solution by lowering the pH with a small amount of hydrochloric acid and some more hydrogen peroxide. I then need to reduce the solution back to around 300 milliliters. I won't be adding anything from that last extraction as I don't want a lot of copper to contaminate the gold. So here's the total gold from the first 2 extractions. It's time now to get all this gold together. After 5 years of use, my hot plate decided to retire itself, so new year, new hot plate. On the left, I have the gold from the pins, and on the right, the chip ash. I'll dissolve the gold in both containers and combine the 2 solutions. I'm adding enough hydrochloric acid to cover the material, and then adding potassium nitrate to create poor man's aqua regia. The potassium nitrate reacts with the hydrochloric acid to produce nitric acid, so this is a cheaper alternative to buying nitric acid. It's also useful for people who can't purchase nitric acid in their country. After a couple of minutes, the gold from the pins is completely dissolved, and I'm getting a nice reaction in the other jug. I'll leave it to react for around half an hour, and I'll get back to you once it's completed. The 2 solutions have been combined, and I've added some water to precipitate any silver chloride. This has to be the greenest solution I've ever worked with. A quick stannous chloride test to make sure there is gold in solution, and as you can see, we have a beautiful black stain. For the precipitation, I've opted for sodium metabisulfite. The gold that drops will probably be very dirty, so once it's settled, I'll boil it in hydrochloric acid to clean it up. I'll see you shortly once it's cleaned. The gold cleaned up beautifully, so now it's time to get a weight. 1.9 grams. That's not a bad start to the year. If you've enjoyed this video, why not check out some of my other content? Also, don't forget to hit the like button.